Hey, this is Mr. Love here again. This is homework 211, part 2 of 2. So this is the back side of that worksheet. Problem 6, which block gets to the bottom of the incline first? Assume no friction. Okay, so unlike the previous problem, which was asking about velocities, this is asking which one gets there first. So this really is it's still a potential energy problem, because if you look at it this way, each block has a certain height above the ground, and so you could figure out the potential energy of this system if they'd given you the information. MGH. But really what's going on here is that this steeper incline is going to allow this block to actually hit the ground faster. So block A is going to be the one, and if you think about it, this has a shorter distance to go than this block does. While block A will hit the ground first, block B, block A and B will achieve the same final velocity because they both have the same potential energy to begin with. Okay, that's number 6. Number 7, the kinetic energy, potential energy of a block freely sliding down a ramp are shown in only one place in the sketch, so they give you both in that one place. Fill in the missing values. For this problem, you need to know that the total energy equals the potential plus the kinetic. Okay, so this is the spot where they give you both the energies, both the potential and the kinetic. So the total energy here is 75 joules, and that means that all along the way at each of these spots, the total energy is exactly 75 joules in every other spot in between. So knowing this piece of information, all you need to do is subtract whatever number they give you, kinetic or potential, from the 75. So in this spot here, they give you kinetic energy equals 50 joules. You subtract that from 75, you get 25 joules is the potential. Here they give you 50 joules as the potential. You subtract that from 75, you get 25 joules as the kinetic. Here in the last, the top spot, again, you know total energy is 75, the kinetic energy is 0. So 75 minus 0 is 75 joules. Okay, number 8 reads, a big metal bead slides due to gravity along an upright friction-free wire. It starts from rest at the top of the wire shown in the sketch. How fast is it moving as it passes point V, D, and E? So if you remember from the previous problem in video number 1, we had an object falling from a height of 5 meters. When that object falls from a height of 5 meters, it reaches a velocity of 10 meters per second. So at point B is going 10 meters per second. And if you wanted to, again, you could calculate that using the distance equation, distance 1/2 gt squared, and the velocity equation. Okay, but we're not going to go through that again. I just did that on the previous problem. And now what you sort of need to realize here is that this line is sort of the reference point for all the energies here. So anytime it crosses this line, this object is going to be going 10 meters per second. Okay, so points D, E are both going 10 meters per second. It's not unlike energy states in chemistry. It's sort of the same thing, right? So when it dips below point B, it's going to be going faster than 10 meters per second. It's going to reach its fastest point at C, so that's this answer here. When it gets back to D, it'll be going 10 meters per second. This point isn't labeled, but if it was up here, it would be going some speed less than 10 meters per second. Okay, and E would be going 10 meters per second. If this continued upward and it had something like this, it would go back up only to the original spot. And actually, I'm going to run out of time for 9. I'm going to skip it. But essentially, what this is talking about is the fact that even wind has mass and it has velocity, so therefore has kinetic energy. That kinetic energy turns the turbines in the fan, and as a result, it removes kinetic energy from the air, making the wind slower.